This is my first time as a speaker here in DevClub. And today I'm going to talk about building scalable on-premise infrastructure using Kubernetes. And a little about me. So I have over 15 years of experience in building and deploying software. And I believe in open source, Linux, Ruby, and JavaScript. And I care about developer experience and happiness. And at MAK IT, we try to use cloud as much as possible. And we use GitHub Actions, so everything is more or less in cloud, so we don't have to wake up at night to fix something and have sysadmins to do things. And it's pretty nice there. And back in 2020, we were one of the first countries to provide contact tracing app, and multiple companies and volunteers were involved in ApturiCovid. And also MAK IT, some employees also joined, and we managed to create backend with all volunteers. I think we were 3 guys doing the backend, and we had a very tight schedule to build this, and we managed to develop and build it in 18 days. So from the first commit to launching in production. We were also involved in another guys from MAK IT also were involved in creating the mobile apps for Android and iOS. But in this talk, I will talk about the backend part and how we deployed the solution to Kubernetes, more from the developer's side, instead of administrating the Kubernetes cluster, but more from the developer's side. And we at MAK IT and in general, what we want as the developers to have is zero downtime deployments, health checks, high availability, automatic failures for database, auto scaling, and no servers to manage and patch because we are developers. And we don't like waking up at night to restart something. And what we usually do, so at MAK IT we do custom software development, and we have a lot of customers, and for each customer we have a separate isolated environment. Someone uses AWS, someone uses Google Cloud, someone uses Azure, someone uses on-premise, so each solution gets deployed differently, and each solution is different. But we mostly like using AWS, and we usually write Terraform to set up all the virtual private networks, all the subnets, databases, and everything is documented as code. So the documentation just says that you should run Terraform apply, and it's up to date. Then we usually use AWS load balancers, and for container orchestration we usually use AWS Elastic Container Service with Fargate, so we don't have servers, and it's in most cases it's enough. And but in some cases we do need Kubernetes, so we have used also AWS Elastic Kubernetes Service. And for the database we usually use RDS, which has a nice feature that you can, with one click or one Boolean, trigger high availability with failovers. And also AWS comes with logging, CloudWatch, and for files we usually use AWS S3 buckets, unlimited storage, cheap. And in some cases we also use CloudFront. And for Docker registries, we push them in inside AWS Elastic Container Registry. And in this case, for this setup, AWS provides a lot of services. So, for example, if a customer doesn't have a data center, doesn't have any accounts, so the only thing they need is to just open an AWS account, add a credit card, and we will take over it and deploy everything there. And what customers usually think they need. Most customers think they just need 1 or maybe 2 virtual machines and everything will work. In some cases, yeah, this is enough. But in case of ApturiCovid, we wanted something that is more stable and scalable. So the ApturiCovid data center offered us using F5 load balancer they had. They had Nutanix Carbon and Nutanix Prism platform set up there, and they had Scale IT S3, like self-hosted solution for S3 buckets. And we did need to fill the gaps in between there. So, of course, we didn't have infrastructure as code. Probably for the Kubernetes part, we had YAMLs, and we didn't use Terraform to actually apply the changes. And for the logging, we used Promptail, Loki, and Grafana, which I'll get into later. And for the CDN part, with only caching, because it's local data center, we used Nginx with caching only. And we stored the source code in GitHub, cloud, like the free version, which comes in GitHub for the teams. It was enough. We also used GitHub Actions with 2,000 minutes limit, which is also free for the tests, running tests, building images. And we pushed the images in GitHub container registry. And so, yeah, why on-premise? So there are multiple reasons, right? So most common are regulatory reasons, security reasons, and costs. And in case of ApturiCovid, which is a government institution, so like the MAK IT, which is the health authority behind ApturiCovid, is a government institution, and they have their reasons. So we needed to use on-premise solution. And this is what we came up, like how the backend and everything looked. So at the start, we also needed to create the landing pages. Like if you go to apturicovid.lv, it will have a landing page there with all the information, the marketing materials, and things like that. And at the start, it was just a static page, but after a few days, right, the marketing team wanted some more changes, and they wanted to change something by themselves. So some volunteers created a simple CMS, custom written in Node and React. And we didn't want to deploy additional database to store everything, so we just used S3 bucket to store the content. And so then we had created the backend administration panel, which is a Ruby on Rails application with Postgres database, which was used by health authority employees to create the upload codes for the people who have been diagnosed with COVID, and they would be sent to SMS and to see some statistics and things like that. And then we also had backend API, which was also a Ruby on Rails app, and the API was used by the mobile apps to submit their diagnosed keys if they have been diagnosed with COVID, and they enter the code provided by health authorities. And also, if you have entered your phone number inside the app, then that's also another case where the API will be used to notify that you have been in contact and that you have maybe been exposed. And then we had the last part, which is like S3 bucket with all the, where we like to store all the exposed, like all the diagnosed keys. And this endpoint will be called by all the mobile apps. So if 2 million users have installed the app, there will be at least 2 million requests per day in the background for each device. Check if there are new batches of diagnosed keys. So we need to make sure that this is available at all the time, and this could scale well also. Because at the time we didn't know how frequently Apple and Google's exposure network will trigger and check if there are new batches available. But then at the end, we noticed that it was probably once a day or a few days, a few times per day. And then the next part, so the ApturiCovid data center provided us with the Kubernetes cluster, and we needed to access it. So there was a UI, but I'm a big fan of using CLI tools. So also the Nutanix provides a command line interface, which is a single binary, and you could log in, like get the kube config, and then you can run your Kubernetes commands there and apply your manifests. This was straightforward, and the only thing, regarding we like packed this inside our deployment script because the kube config was valid only for 24 hours, and using the UI every day was just not the easiest way and the fastest way to do this. And the next part, like the next challenge, was actually like getting traffic inside the Kubernetes cluster so we can actually receive the requests. So what they did was they installed F5 load balancers, added HTTPS SSL certificates using Let's Encrypt, and they forwarded all the traffic to the Kubernetes cluster. And inside the Kubernetes cluster, we installed Ingress engines, and we specified to use node port 30,000 because otherwise it would just associate random ports. And at the cluster, we had 3 worker nodes where we could deploy our solution. The deployment process was kind of straightforward. In our Git repository, we created a Git tag with like a version number, and we have set up GitHub Actions to trigger a workflow to actually build the Docker image and push it to the Docker image. And then we would be able to deploy this to Kubernetes, right? We updated the Kubernetes manifests and applied database migrations, waited before they finished, and then applied the deployment. And Kubernetes takes care of all the rest, right? Doing rolling restarts. We also did set like resource limits and everything with health checks, so everything was running smoothly. So at the end, we had used Ingress service deployment. We had cron jobs to like publish the batches each day, and we had in staging, we had 2 environments. In staging environment, we had only 1 master node and 2 worker nodes because it wasn't critical. But in production, they provided us with 2 master nodes and 3 worker nodes. And one of the volunteers also did a load test, and they were using tool Locust. It's an open source load testing tool, and it's a great tool. So you write like your flow for the testing using a Python script. Then you can start a bunch of like workers on separate servers if you want. You can just load test from your local machine, but like to really test and avoid having some network latency issues and network bandwidth issues. So you want probably do the load test from multiple servers at the same time. And in this case, when doing the load tests, the first thing that came up was that Ingress engines was failing. At some point, we noticed that for a minute, none of the requests were going through. And so the problem was that engines process started crashing, and Kubernetes did the health checks like liveness probes and things like that, and it restarted the pod and container after a minute or something. And the quick fix here was just to increase the replicas from 1, which is the default one, to 3 replicas, and it became much more stable. It's still Sometimes one of the engine's processes still crashed, but we didn't care because we had at least 2 more. So then the next thing, we tried testing these exposure keys download API, which is the API that's going to be called by all the mobile devices in the background. So at least 2 million requests per day, if there are 2 million apps installed. So the first thing, we tried like directly from the mobile app, connect to Scality S3 service, and I think it could handle only around 2,000 requests, and then it just didn't accept any new requests. So we tried configuring F5 proxy to do some caching, because these batches, when they are published, they don't change. The only thing that changes is like the index page, which has references to all the new batches published. But the batches doesn't change. So, and then after this didn't work, so we deployed like separate Nginx pods inside our Kubernetes cluster, and we did use proxy cache, and we managed to squeeze out 600 requests per second, and it was good enough. And then for the monitoring part, to actually see what's happening, we installed Grafana and Prometheus, and also the Ingress Nginx comes with examples how to do this, and actual dashboard examples how. So on the right side, there is the real from the testing when we are doing the load testing. So you can see that there are 6K requests and 10,000 connections. And for the application monitoring, we used a cloud solution, New Relic, which is free. You can see 2 days of application insights, and it was good enough and easy to set up for a Ruby on Rails application. And then we needed to figure out how to get logs, because by default Nutanix comes with, I don't know, default Docker configuration, and the log files were, I don't know, log rotated or something, but we couldn't access more than, I don't know, 6 hours of previous data. So we did install Promptail and Loki. Another solution would be to install the Elasticsearch and Kibana, but I think this was more lightweight and easier to set up. We already had Grafana, so we used this, and the Loki provides LogQL language to query the logs. So we were able to also show some graphs in Grafana. So on the right side, you can see a chart with per minute how many downloads were done for these keys, and in this 24-hour, you can see how many requests per day were done. And everything went smoothly. So, and after a while, there was an update. So we needed to add this European Federation Gateway service to actually exchange the infected keys with other countries. So, for example, if you have gone to Italy and you have met someone which has COVID, right? The other person in Italy probably uses Italian health authority application for contact tracing, and so this is the way how all the European countries could exchange their infected keys. And this EFGS was an open source project in GitHub. We also did some pull requests to fix some things there, and at some point we needed to test this. How does it actually work in our app? So, and what we did, we deployed a clone of our backend also to the same Kubernetes cluster, just by copying all the manifests, renaming the names, and it was kind of almost what we needed, except the EFGS service didn't include, they used like client-side certificates for authentication, and inside the repo there wasn't like anything that shows you how can you like send them to the AFGS server. Probably they used some proxy in front of them, but it wasn't available in the GitHub repository. So to be able to use client-side certificates for our testing and staging environment, we first tried using Nginx, but actually Nginx didn't had the SHA-256 fingerprinting. It had only SHA-1, so we needed to find another solution, and we did find that Envoy proxy supported that. It was a bit hard to configure it because it's really complex and like flexible solution, but we did manage to do this and deploy the AFGS behind the Envoy proxy, and we managed to test this locally. And so my final thoughts, this was my first like Kubernetes deployment. It was fun, and I think Kubernetes is very flexible, and on-premise deployments are challenging and requires more things to keep in mind, and probably like configuring this F5 proxy in front of these things could make change, right? Because in cloud environments, if you install an ingress, it's probably already configured for the managed Kubernetes service you're using in AWS or Google Cloud, so it automatically provisions a load balancer in front of it, and everything kind of just works. And in our case, we just used plain YAML files to apply the changes, but we couldn't share, like we just copy pasted like some YAML files, and another way how to use this is customize, which we have used in different projects, so you can like share the YAMLs and override just the parts. For example, in staging you want 3 replicas by default, and in production you want 20 replicas by default. So this is an easy way how to avoid repeating yourself and just copy pasting these YAML files. Another solution we have used is using Helm. We created our own Helm charts for each our application, and it's also a great way, so you can actually install, and if you uninstall the Helm chart, also the all resources are gone from the server. And probably in this case, the architecture could be simpler. We probably didn't need that much nodes. Like we probably could have stick with 3 worker nodes, but smaller in the size, because 600 requests was like more than enough. In the real world, we had like 3 requests per second, so it was overscaled. So probably the right way to do this would be to scale down, actually, so we were overscaled a bit. And probably we should figure out how to store logs maybe somewhere else, because if the cluster goes down, so probably you don't have anything to like investigate before someone takes care of making sure the cluster runs again. So probably the monitoring and logs could maybe be deployed to some other cluster, or I don't know. So yeah, that's it. Thank you.
I have one question.
Yeah.
It's not so technically, but I'm very interested to know if it's possible to share with us, and you have this information. Could you explain what's the correlation between events in application when people, when somebody connects to our person, and after that, that somebody even.
I'm not sure I understood you. Can you explain again?
What's the correlation between events when somebody people who use this application connect in person, and after that, this somebody goes to you.
Well, so the mobile devices, they generate like new keys every 15 minutes. And if, for example, if we have been in contact for 2 minutes, right, the mobile phone logs the keys they have seen around. And then if I got sick, for example, right, the Beigarts would contact me, maybe. They don't always do that. And if I have positive test, then they would provide me the code. I would enter my mobile phone, and then my mobile phone would send my keys to our backend. And then at the end of the day, Beigarts would submit a new batch with all the infected keys for the last 24 hours. And your mobile device, probably at night or early in the morning, would check for new batches, and then you would receive the notification.
Okay, and do you have statistics between events that somebody contacts a sick person, and after that he goes to sleep? Sorry.
I think we don't have like much more, because most of the data are anonymous, so we don't actually know, and in some cases, if you don't have...
That's a very interesting moment, because it's the main idea how this application can help others to, when I connect to somebody who's sick, and after that I will...
Yeah, probably we could like improve this, because currently we are doing these batches only one per day, because at the start, this Apple's and Google's exposure notification framework had limits that it could handle only 15 batches for like each per day. And I think it's probably much better now. So we actually need to probably implement these new exposure notification APIs, and think if you can improve like the time before you get notified. And probably also we could get some like statistics, how fast this happens maybe. Anyway, we could try figuring this out.
Question from my side, more technical. You mentioned that you basically had a problem with Grafana, well, not maybe a problem, just part of configuration, that it only stores the logs like for 6 hours. I think it's default memory configuration. So I was just wondering whether have you considered maybe federating Prometheus to actually retain those logs for a longer period? And the second question, also related to the Grafana, did you actually expose it and try to secure it with any authentication services? Did you have any problems with that?
We didn't try that. For example, for Grafana, we just port forwarded the port and opened it locally, so no authentication there. So we didn't expose it anywhere.
And what about the federation with the Prometheus?
We didn't check that.
What is the difference between a phone and public visitor?
Public visitor is the one who actually opens the web page for ApturiCovid.lv to like read the information from your computer or from your mobile phone. Yeah, from the mobile device is using the apps.
On one side, by getting case, it's exposed, sending personal information about numbers, so our can communicate, like this. From one side, phone getting this exposed case and checking does there was some communication with exposed persons, and if I know I'm with some deal with COVID, I'm posting my number and sending his number to Beigarts or something to them, letting them know someone about this.
Yes, so letting them know that I have been in contact. And they will probably contact you and ask you if you have symptoms and things like that. And if you haven't entered the number, so you're completely anonymous, and the only thing you are doing is just connecting to S3 proxy to get the...
But not working on other side. Yeah, if I'm sending, was exposed, I'm seeing my case, I understood this. Okay.
you guys have open source the app?
For the mobile apps for iOS and Android are open source. They are in, so I will show you. So the repo is, the organization inside GitHub is called ApturiCovid. And there we have the Android and the iOS apps there. So if you find a bug, so feel free to open a pull request.
Okay, Edgars, thank you.